question is, let A be a m by n matrix with all non-zero real entries, which means all elements are non-zero elements. Let B be obtained by from A by replacing A11 by 0 and keeping all other entries unchanged. If R is the rank of A, then what is the set of possible values for rank of B? Now, the best way to attack such problems is to take an example. Let's say A is a 2 by 3 matrix, and we take two examples. Example 1, the elements are 1, 2, 3, 4, 9 and 11. And example 2 is we take 1, 2, 3 and we have 2, 4 and 5. Now, what happens? If I replace the first element of both the matrices by 0, which means this is replaced by 0 and this gets replaced by 0. Now in the first case, the matrix becomes A equal to 0, 2, 3 and 4, 9, 11. Now notice that in the first case, the rank of the matrix is 2 because we have 2 rows. Number of rows is less than the number of columns and both rows are independent of each other. This was the original form of the matrix. And when I replace the first element with a 0, then nothing changes because again both the rows are independent. So the rank of this matrix would be 2 again. But what about the second case? In the second case, in the original form of the matrix, the rank was 2. But when I replace it with 0, the second row becomes a dependent row because the second row can be derived by just adding 2 with the elements of the first row. So 0 plus 2 becomes 2, 2 plus 2 becomes 4, 3 plus 2 becomes 5. So which means there is only one independent row. That means the rank of this matrix after it is changed with a 0 is 1. The rank of this matrix is 1, which means that there can be two cases where we can have the rank unchanged. So if R is the rank of the original matrix, the rank of the changed matrix would also be R. Or if R is the rank of the original matrix, then R minus 1 would be the rank of the changed matrix. So there could be two possibilities, R minus 1 and R. So option D is the correct choice. We look at another question. This one says, what is the period of the function gx defined by mod of cos x plus mod of sin x? Now, we have to first understand what is meant by period of a function, especially oscillatory functions. So if I plot x versus sin x, then the curve will look like this, where x is 0 and sin x is 0 at the point 0, and then at the point pi by 2 sin x takes the value of plus 1, and then at the point pi sin x again comes back to 0, and at the point pi plus pi by 2, which is 3 pi by 2, sin x takes the value of minus 1 and then again comes back to 0 at 2 pi. So the entire range of x for which that covers all the possible values of sin x is 0 to 2 pi. So the period of this function sin x is 2 pi. So now we look at the given function. So if I plot this function, sin x, mod of sin x plus mod of cos x will always be positive. So if I plot this against x, gx versus x. So at x equal to 0, we will have cos x equal to 1. Our mod of cos x is plus 1, so it will be plus 1. And then at x equal to pi by 4, both cos x is 1 by root 2, and mod of sin x is again 1 by root 2. So the addition of that would be 2 by root 2 or root 2. So at x equal to pi by 4, the value of this function is root 2, becomes root 2. Again at x equal to pi by 2, the value of the function becomes plus 1. So the curve clearly would be like this between 0 to pi by 2. Now what happens in the second quadrant between pi by 2 to pi? Now at 3 by 4 pi, cos x would be negative or minus 1 by root 2, but mod of that will still be 1 by root 2. So again, mod of cos x becomes 1 by root 2. Mod of sin x obviously in the second quadrant would be positive, that is 1 by root 2. So the function becomes root 2 again. So which means that at 3 pi by 4, this becomes root 2 again, and it will come back to plus 1 at pi, x equal to pi. So this pattern will keep repeating between every pi by 2 intervals. So therefore 0 to pi by 2 or pi by 2 to pi or pi to 3 pi by 2 are the intervals which covers all possible values of this particular function gx. Therefore the period of this function is pi by 2. We look at the next question, which says if 3 cos 100 degree plus I sin 100 degree multiplied by cos 110 plus I sin 110 is equal to x plus iy, where x and y are real numbers, then find the value of x and y. So we just simplify this. So we can write this as cos of 100 plus I sin 100 multiplied by cos 110 plus I sin 110 is equal to x by 3 plus I into y by 3. So we expand the left hand side of the expression, which will give us cos 100 into cos 110. So the first term of both the expressions, and then we take the last terms of both the expression, because I square will become minus 1. We have to segregate the terms with I and without I. So we get minus sin 100 sin 110, because I square is minus 1. So that's why the minus came. Now we cross multiply the other two terms, which means cos 100 with I sin 110. So that means plus I cos 100 sin 110 and I sin 100 with cos 110 plus cos 110 sin 100. So this is equal to x by 3 plus I into y by 3. So now we have segregated the terms with I and without I. So therefore we can simplify this. We can see that the first bracket term contains cos A cos B minus sin A sin B, so which is nothing but cos of A plus B, or cos of 100 plus 110 plus I cos A sin B plus sin A cos B. That means sine of A plus B, or 100 plus 110. This is equal to x by 3 plus I y by 3. So therefore x is equal to thrice cos of 210 or thrice cos 180 plus 30 or thrice minus cos 30, because cos of pi plus theta is minus cos theta. So this is minus 3 cos 30 is root 3 by 2. So x is equal to minus 3 root 3 by 2. So we can clearly see that option A has x equal to minus 3 by 2 and option D has x equal to minus 3 by 2. So we can clearly cross out the other two. Now we check for the value of y. So y is equal to thrice sine of 210. We just equate y by 3 with sine of 100 plus 110. So this is nothing but thrice sine 180 plus 30. Again, sine of pi plus theta is minus sine theta. So this is thrice of minus sine 30 or minus 3 by 2. So y equal to minus 3 by 2, which is the first choice, or option A is the correct answer. We come to the next question, which says what is the number of 6-digit positive integers in which the sum of the digits is at least 52. Now what does this mean? So we have a 6-digit integer, 6-digit, and the sum of all the digits is at least 52. So what can be the maximum value of the sum of the digits? So each of the digits can be maximum 9, each digit. So there are 6 digits. So therefore max value of sum of digits can be 6 into 9 or 54. And here we are told that it is at least 52. That means it should be either 52 or 53 or 54. So clearly 54 will mean 6 into 9. So this is one case. 53 and 52. Now if I have to have 53, that means I have to have 5 9s. So 9 into 5 is 45 plus 1 8. 9 into 5 is 45 plus 1 8. This is the only combination which gives you 53. What about 52? 52 can be obtained in two ways. I can have 5 9s plus 1 7, which gives me 52, or I can have 4 9s plus 2 8s. This also gives me 52. So this is these are the possible combinations of digits that we can have. Now let us look at how many such combinations will exist. So for 54 there is one combination which is all 9. So this is one combination. For 53 there would be 1 8 1 8 plus 5 9s. That means I can put the 8 in any of these places, either here or here or here, anywhere. So I can have 6 possible ways to put the 8, and all other places will be occupied by 9. So there will be 6 ways of doing this. 6 ways of doing this. And for 52 I will have two possibilities, 5 9s and 1 7. So again the same logic applies. If I have 5 9s and 1 7, there will be 6 possible ways of putting that 7. But what happens if I take this combination, 4 9s and 2 8s, which means that, let's say I pick the first position for the first 8, then I can have 1 2 3 4 5 places to put the second 8. So for 8 in the first position, I can have the second 8 in 5 positions. For 8 in the second position, I will have 1 2 3 4 places to put the second 8. Mind you, you cannot take this because I have already considered this combination when I took the 8 in the first place and 8 in any of the other places, which means 8 in the second place as well. So when I'm taking 8 in the second place, don't consider 8 in the first place. Look at the forward spaces. So there are 4 spaces for 8 in the second place. Similarly, 8 in the third place would mean the second 8 would be in any of the 3 remaining places. Similarly, 8 in the fourth place will give me 2 spaces to put the second 8, and 8 in the fourth place will give me just 1 position, which is the last position to put the second 8. So this is nothing but 5 plus 4 plus 3 plus 2 plus 1, which is 15. And this is the total number of combinations. So this means I can have 21 combinations here, and 6 for 53 and 1 for 54. So which makes it 21 plus 7 or 28 total combinations. So option C is the correct choice. We look at the next problem, which says we have a sum of a series 3 plus 33 plus 333 goes up to right up to 200 times of 3, and the sum of this can be expressed as some series of digits in the decimal system. So where x is the last digit or the unit digit, y is the 10th digit, and z is the 100th digit. So we are asked to find the 100th digit of this sum. Now how do we approach this problem? Well, the simplest way of doing this is, first consider, this is elementary addition. So first consider the last term, which is 200 threes. Then the next term will be 199 threes. 199 threes. And so on. So the next one would be 198 threes, and so on. And the last 3 terms would be 333, 33 and 3. So I have 200 threes here, and this is the 203, and this is just 3. So I have the last digit running from 1 to 200. So there are 200 threes in the last column. There are 200 threes in the last column. So that means for the last column or the unit digit, I will have 200 threes, which is 600. So that means the last digit would be 0 and 60 would be carried over. Okay, now we come to the unit digit. Now the unit digit will have 199 threes plus 60 carryover. See, the unit digit ends here, so there are 199 of them. So that is nothing but 597 plus 60, which is 657. So the last digit comes down here, so 7 comes down here, 65 is carried over. So now we come to the 100 digit. So there will be 198 threes in the 100 digit plus a carryover of 65, which would be 594 plus 65, which would be 659. So 9 comes down here and again 65 gets carried over here, but we only want the 100 digit, so the 100 digit would be 9.